Okay guys, Chapter 14, Heat Problems. This is exercise 14G, and this is where we add heat to really cold ice or just some starting temperature, and we want to know what the final temperature is given the amount of heat that we add. The key to this problem is do the problem just like we do all of them, one step along the heat curve at a time. The total heat is like a gift card, and each step along the heat curve is sort of like a price check. And so every time you do a calculation where do I have enough heat to get from this temperature to the next? And then you have to make a decision along the way. Best way to do this is to do some problems. I have 3 different problems here. We'll do the first 2, and if you want to write this third one down, you can hit pause real fast, write these down. Okay. And then here's a third problem. Write this one down. Okay. Hit pause, write it down. Okay. So let's go through our problems and our methodology. The quicker you are with this, the better off you're going to be. So, here's how we go about our business. It's the same way every time. Our first step is ice at minus 22. We have to heat up the ice. You have to remember that this is H is equal to mc delta T. So it's 11 times the heat capacity for ice, which is 0.498 calories per gram per degree C, and the temperature change is 22 degrees C. So let's see what that value is. That value is 11 times 0.498 times 22, which is 121 calories needed. Now you can I think it's really important that instead of writing this down from a add them all up, you think about this as a price check. 1425 calories is what we started with, right? If this is how much we need to get that first transition to happen, well, it's clear that you can do that, right? So let's calculate how much is left. That's 4013. So that's how many calories are left. We can do the next step. Ice at 0 to water at 0. That's mass times the heat of fusion, or 11 grams times 79.71 calories per gram. How much is that? 79.71 times 11 is 877. That's how much we need, right? Needed. Yeah, we have enough. Good. What's the difference? Because that's how much is left. Well, that's 7, and that's 2, and that's 4. Let me make sure I did that right. 1304 minus 877. 427. Good. Okay. Now what? Well, let's see if we can get from water at 0 to water at 100. That's H is equal to mc delta T again. This time it's 11 grams times 1 calorie per gram per degree C times 100. So it is 11 times 100. It's 1100. Okay. What do you think? Not enough to get to 100 degrees C, right? Isn't that what that says? All right, so how far can we get? Well, think about it. If it takes 1,100 calories to get from 0 to 100, and we have 427, isn't that about a little bit less than half, right? If it's a little bit less than half, maybe the final answer is going to be about, I don't know, maybe about 40 degrees. You with me? It would take 550 to be exactly halfway between 0 and 100. So that's sort of a way to estimate. So how do we go about doing this problem? Well, now the problem becomes 427 calories added to 11 grams at 0 degrees C equals what? Okay? Well, we've already done that kind of problem before. We've done that problem a lot. And I think I'll do that problem right here. H is equal to MC delta T. Heat, mass, delta C. So delta T, right? That's what we're solving for. Alright? So the delta T is equal to the heat see if I can find a pencil that works, which I can. Okay. Delta T is equal to H over MC. H is 427 calories. M is equal to 11 grams. We are at the liquid water stage, so we're using 1.00 calories per gram per degree C. Okay, so what is 427 divided by 11? 38.8 or 39 degrees C. Now let me jump down here and squeeze this in here. The change in temperature is 39 degrees C, yes? Okay, but where did we start? We started at 0. And then we heated it up to 39, and then we ran out of heat. So for this case, the temperature final is equal to 39 degrees C. Alright. That problem has us finishing, if you look at the heat curve, we were able to heat up the ice and melt the ice, but we only got about halfway up the hill before we ran out of heat, ran out of gas, okay? Ran out of money. Alright, so that's that problem. How do we go about this problem? Okay, well it's the same sort of deal, right? I'll see if I can squeeze this in a little better so we have more room. Ice at minus 12. Ice at 0. H is equal to MC delta T. 14 grams. 0.498. 12 degrees C. We started with 5425 calories. Alright, let's see. 14 times 0.498 times 12, 84 used. Okay, the difference between them $54.25 minus 84 is 53.41 calories left. Ice at 0. We're going to warm up the water. Heat of fusion times the mass. 14 grams, 79.71 calories per gram. That's the amount of heat that you need. Okay, let's see where we're at. 14 times 79.71. Do we have enough? It's 1,116 calories used. Sure, we got enough. Let's see what the difference between 53.41. We started with $5,425. We spent $84. Now we spent $1,116. How much money do we have left on our gift card? 42.25 calories left. Good. Now what? Well, let's see if we can buy another jump. Water at 0. Water at 100. MC delta T 14 1 100. That's 1400. We got enough. Good. Let's see how many calories we have left now. 5, 2, 8, 2. Gotta make sure I don't trust myself. 28, 25. Good. All right. Still got money to spend. Let's see if we can get the water at 100 to turn into steam at 100. Heat of vaporization times the mass, this times 14 grams, 539.5, 539.5 calories per gram times 14 grams means 7,553 calories needed. Alright, so what does that tell you? Not enough to convert all liquid into steam, right? Isn't that what that says? You need 75.53 to get from 0 to 100, but you only have 28. So maybe you finish here, right? Something like that. Well, you finished the temperature final. It's going to be 100. A combination of water and steam. Everybody with me on that? You converted some of the water into steam, but you ran out of heat to get it all to convert. Alright? That's the deal on that one. Okay, good. One more problem to go. Let's see where we're at. 2,200 calories, 5.5 grams of ice at minus 28, final temperature. Okay, same deal. ice, minus 28, ice, 0. H is equal to MC delta T, always, whenever we have the same state of matter. Calories, okay, so 5.5 grams, 0.498 calories per gram per degree C, 28 degrees C temperature change. So what is 5.5 times 0.498 times 28? 77. That's how much we need. We started with this many. So the difference is how much is left. We just spent $77 out of our $2,200 gift card, which means we've got 23 calories left. Okay, good. Now what? Ice 0 to liquid at 0. We're going to melt the ice if we can. Well, what is 5.5 times 79.71 calories per gram? 5.5 times 79.71 equals 438 calories needed. Excellent. We still have some left over. How much? 23 minus 438 is 1685 left. Okay, so we've got some left. Good. Let's find out if we can buy the next transition. Liquid at 0. To liquid at 100. H is equal to MC J's delta T. So this is 5.5 grams, 1 calorie per gram, and yeesh, pencil, destruction here, 100 degrees C. So 5.5 times 100 is 550. Hey, we still have enough. Good. So that means how much is left? 5311. Liquid at 100. Steam at 100. H is equal to M times heat of vaporization. Well, what are we talking about here? We're talking about 5.5 times 539.5. Need 2,967. Well, what do you think? Not enough. So the final temperature is going to be equal to 100 again. Alright, but what if, and I think I messed up the problem a little bit for what I wanted to show you, so let's play with this and say this was 1,220. What if it was? Well, okay, that was quick. That was for the original. Can you see that now we would have enough? This was the part I wanted to do to help you out. 11135 minus 2967 is 8168 calories left. If you had this many calories left, now what? Well, we will be going steam at 100 to steam at, I don't know. So how do you handle this problem? It's pretty simple. Let's move over a little bit, sorry about that. Now it becomes, if 8168 calories are added to 5.5 grams of steam at 100 degrees C, what's the final temperature? Can you see that that's what we're doing here? We're adding this much heat to this much steam at that temperature. Where do we end up? We need that temperature again. So we're setting this up the same as we did before. Delta T is equal to H over MC. The heat is 8168. The mass is 5.5 grams. And the heat capacity is what? It's steam's heat capacity. What is steam's heat capacity? Well, that's joules, 0.480. Calorie per gram per degree C. The final temperature is degrees C. That's what delta T is. What is 8168 divided by 5.5 divided by 0.48? It's 3094 degrees C. And that's the change in temperature. And we started at 100 and we added this. I'm going to be happy with 3194 degrees C as the final temperature. I can also see if somebody decided that this was a 2 sig fig calculation, that you would write 3, let's see, where would I draw that line? 2 sig figs. 3.2 times 10 to the 3rd degree C. I gotta admit, I'm probably gonna give you credit for both. Since we're adding heat and we're adding all the heats to the one's place, I'm gonna be satisfied with either one of these calculations. Okay? So, the take-home message here. Go all the way back. See the original heat curve. If you finish here, or finish here, or finish here, you're going to have to do a calculation where you say, this much heat is added, where do we end up? Otherwise, if you finish here, or finish here, the final temperature is either going to be 0 or 100. Okay. Get at it, work hard, Do the calculations. Good luck.